It is very late now, in a tall building somewhere in a quiet part of the city. The last occupants left hours ago. The lobby lights have dimmed themselves down to a soft, low glow, the kind of light that seems to exist only to reassure, not to illuminate. Outside, the streets are mostly empty. Inside, the halls are still. And yet, behind one set of closed steel doors, something remains awake, not moving, not needed, not right now, but awake in its own quiet way, the way a house settles at night and yet still hums faintly with electricity behind its walls. You have probably stepped into an elevator more times than you could ever count. Millions of people do, every single day, all over the world. They step in, they press a button, they look at their phone or gaze quietly at the doors, and a few moments later they step out onto a different floor. It feels so simple, so ordinary, so unremarkable that most of us never think about it at all. And yet, behind that simplicity, there is an entire hidden world of engineering, patiently doing its work, floor after floor, day after day, without ever asking to be noticed. Tonight, we're going to explore that hidden world together, slowly, gently, the way you might wander through a quiet museum after hours, when no one else is around and every sound feels a little softer. There's no need to hold on to every detail. You can simply let the information drift past you, the way passing floors drift past a small window, one after another, softly lit, gone as quickly as they arrived. An elevator, at its heart, is not really one single machine. It's a whole coordinated system, many separate parts, working together in a kind of slow, careful conversation. There are mechanical parts, the ropes and rails and wheels that physically move the car. There are electrical parts, the motors and wiring that provide the necessary power. And there are control parts, the quiet electronic minds that make the decisions, moment to moment, about when to move, when to stop, when to open the doors, and when to simply wait. Mechanical, electrical, and control, three quiet layers, resting one on top of the other, like blankets, each one doing its own gentle work. And what's interesting, what's worth resting your mind on for a moment, is that this system never fully stops paying attention. Even right now, in this late, still hour, with no passengers anywhere nearby, the elevator is still, in its own way, awake. It is still monitoring its own position within the shaft. It is still aware of its own speed, even though that speed is currently 0. It is still checking that its doors are properly closed. It is still confirming that its safety systems remain armed and ready. All of this happens continuously, quietly, without any lights flashing, without any sound at all, just a steady, unhurried exchange of small signals, back and forth, like a slow and patient heartbeat somewhere deep inside the walls of the building. This is one of the reasons elevators are considered among the most reliable forms of transportation in the world. Not because they are exciting or fast, but because they are so carefully, continuously watched over. Every part of the system is built to check itself, and to check the other parts around it, again and again, softly and repeatedly, the way a lighthouse keeper might glance at the same dials every hour through the night, not because anything is wrong, but simply because watching is part of the job. Even now, while the building sleeps, the elevator remains powered. Its systems remain live. Somewhere, a small current moves quietly through its wiring, keeping its sensors alert, keeping its control panel gently humming, keeping everything ready to respond the moment it's needed again. It doesn't rest the way people rest. It simply waits, in a state of soft readiness, the lights on its control panel glowing low and steady, like the tiny embers of a fire that has been banked for the night but never fully extinguished. Let's move closer now, gently, toward the space where all of this happens. Not the small room you step into, not yet, but the long vertical passage that surrounds it. This passage is called the hoistway, though many people simply call it the elevator shaft. It's a tall, narrow column that runs straight up through the building, floor after floor after floor, often from the very bottom to the very top. If you could see inside it right now, past the doors, past the walls, you would find a space that feels almost like the inside of a great quiet chimney, dim and vertical and softly humming with unseen activity. Inside this shaft, fixed firmly to the walls on either side, run two long metal guide rails. These rails stretch the entire height of the building, perfectly straight, perfectly vertical, like two long, quiet lines drawn from the ground floor all the way up to the roof. Their only purpose is to guide the elevator car, to hold it gently in place as it rises and falls, so that it never sways, never drifts, never moves anywhere except directly up or directly down. There is something very calming in that idea, a path already decided, a boundary already set, nothing left to wonder about, nothing left to control except simply moving forward along a line that has already been made safe. Attached to the car itself are small roller guides, sometimes just a few inches wide, that glide along these rails as the car travels. They turn softly, smoothly, almost silently, keeping everything aligned, keeping the ride steady. If you rested your hand against the wall of a moving elevator car, you might feel the faintest vibration from these rollers, so faint it barely registers, more a feeling than a sound. Scattered along the height of the shaft, spaced out floor by floor, are small position sensors, quiet little markers that allow the system to know at every moment precisely where the car is. These sensors don't need to think or calculate anything complicated. They simply notice gently as the car passes by, and they pass that information along to the control system elsewhere in the building. It's a little like footsteps counted softly in the dark, each one confirming, yes, we are here now. Yes, this is where we are. Nothing lost, nothing uncertain. Running alongside all of this, tucked along the walls of the shaft, hidden mostly from view, is wiring. A great deal of it. Cables and wires that carry both power and information, threading their way up through the building like long, quiet nerves. They carry the electricity that allows the motor to turn. They carry the signals that tell the control system what the sensors are noticing. They carry the small currents that keep the lights inside the car glowing and the currents that keep the emergency systems alert. All of it hidden, all of it constant, all of it working steadily behind the walls without ever needing to be seen. And running throughout the entire shaft, layered quietly over every mechanical part, are the safety devices, the quiet guardians of the whole system. Devices that watch the car's speed, devices that watch the tension of the cables, devices that would, if ever needed, apply gentle but firm force to slow or stop the car safely. These systems exist for moments that almost never come, and that's precisely the point. They wait, patiently, hopefully unused, the way a spare blanket waits folded in a closet. present simply in case the night grows colder than expected. At the very bottom of the shaft, beneath the lowest floor the elevator ever visits, there is a small quiet space called the pit. It rests below everything else, a shallow, dim little chamber that most people will never see in their entire lives. Inside it, buffers wait quietly, springs or hydraulic cushions built to offer one final layer of gentle softness should it ever be needed. It almost never is. The pit exists the way a safety net exists, beneath a high wire, present, patient, hopeful that it will remain forever unused, and yet steady and ready all the same. Let's rise back up now, gently, out of that quiet lower chamber, back up through the long vertical shaft, past the rails, past the sensors, past all that hidden wiring, until we arrive again at the small room that most people simply think of as the elevator itself. This is called the cab, or sometimes the car, and it's really the only part of the whole system that passengers ever actually see or touch. The cab is, in its own way, a small enclosed room built to move safely through a very tall building. Its walls are supported by a sturdy structural frame, a kind of internal skeleton that holds everything together, strong enough to carry passengers safely, yet built with careful attention to keeping the ride smooth rather than rigid. Around this frame, the walls themselves are often finished in soft materials, sometimes brushed metal, sometimes wood paneling, sometimes simple painted panels, chosen not just for appearance, but to remain calm and unremarkable, so that riders barely notice their surroundings at all. At the front of the cab are the doors, which we spoke gently about before, moving with careful cushioned motion, opening and closing under the watch of their own small dedicated motor. Along the top of the cab, soft lighting glows evenly, chosen deliberately to avoid harsh shadows or flickering, so that the small room always feels calm, always feels gently lit, day or night. Somewhere near the ceiling, quiet ventilation systems work continuously, drawing in fresh air, keeping the small space comfortable no matter how many people might be standing inside, or how long the car might travel between floors. You may never have noticed this ventilation before, the soft, steady airflow moving invisibly around you, but it has always been there, quietly doing its part. Near the doors, a small display panel glows gently, showing the current floor, sometimes an arrow indicating direction, up or down, rising or falling, and just beside it, a row of buttons rests along the wall, each one lit softly from within, waiting patiently for a fingertip to choose a destination. And tucked somewhere within the panel, often marked with a small telephone symbol, is an emergency communication system, a quiet, reassuring presence built into every modern elevator. It exists so that even in the rare event of a problem, help remains only a few words away. A soft voice on the other end of a hidden line, awake and listening, even in the middle of the night, even when everything else in the building feels perfectly still. All of this, the shaft and the rails and the sensors and the small quiet room we step into, is only the beginning of the story, because none of it would move at all without the quiet strength of a motor turning somewhere above and the careful pull of cables stretching down through the darkness of the shaft. And that, gently, is where we'll go next, up toward the machines that lift us, up toward the quiet mechanical heart of the elevator, still resting now, still waiting, still patient in the dark. Let's rise now, slowly, up through the quiet shaft, past the rails, past the sensors resting patiently in the dark, up toward the very top of the building, where the elevator's true source of movement waits in quiet stillness. This is the machine, the part of the system that most people never see, never think about. And yet it is here, in this small hidden space, that the whole gentle process of lifting begins. In many buildings, this space is called the machine room, a small enclosed area at the top of the shaft. Sometimes just a modest room with a locked door, humming softly with quiet electrical presence. Inside, you might find a large motor resting on a steel frame, still and silent for now, waiting the way all patient machines wait, without urgency, without any need to prove itself. Beside it, a metal cabinet glows faintly, small indicator lights blinking slowly, evenly, like the gentle breathing of something resting rather than something working. This is the motor controller, the quiet decision maker, that will soon tell the motor exactly how to move, exactly how fast, exactly how gently. Many modern buildings no longer need a separate machine room at all. Instead, the necessary equipment is built directly into the shaft itself, tucked quietly near the top, taking up only a small amount of space, hidden almost entirely from view. These are sometimes called machine roomless elevators, and though the equipment is smaller and more compact, it performs exactly the same quiet, careful role. Whether the machine rests in its own dedicated room or tucked gently into the shaft alongside the rails and cables, its purpose remains unchanged. It exists simply to provide the elevator with the smooth, steady energy it needs to rise and fall. Let's think for a moment about what kind of movement an elevator uses. Most elevators, especially in taller buildings, rely on something called a traction system. The word traction simply means grip, the gentle, firm hold that allows one surface to move another. In an elevator, this grip happens at a large wheel called a sheave, mounted horizontally at the top of the shaft, its surface grooved carefully so that steel ropes, or in some modern systems, flat steel belts, can rest along its edge without slipping. Picture this sheave now, resting quietly above the shaft, a smooth, sturdy wheel, its grooves cut with careful precision. Draped over it, steel ropes hang down on either side, one side connected to the elevator cab, the other side connected to the counterweight, which we'll speak of gently in just a little while. When the motor turns, it turns this sheave, and as the sheave rotates, the ropes draped over it begin to move as well, sliding gently along its grooves, lifting the car on one side while lowering the counterweight on the other. There is something very soothing in imagining this motion slowly, almost frame by frame. The motor begins to turn, not suddenly, not sharply, but with a long, smooth increase in speed. The sheave responds, rotating just as gently, just as gradually. And high above, at the very top of the shaft, this quiet rotation begins to pull, softly, on the ropes below. In many modern high-rise buildings, the motor connected to this sheave is what's called a gearless traction machine. The word gearless simply means that the motor is connected directly to the sheave, without any intermediate gears slowing or adjusting its rotation. This allows for an especially smooth, especially quiet motion, the kind of motion that barely announces itself at all. Instead of a series of clicking gears translating power step by step, there is simply one smooth, continuous turn, motor and sheave moving together as though they were a single, calm, unified object. Resting near this motor, quietly monitoring everything, is the motor controller we mentioned a little earlier. This controller doesn't simply switch the motor on or off the way a light switch might. Instead, it manages the motor's movement carefully, continuously, adjusting speed in long, smooth curves rather than sudden changes. This is done through something called a variable frequency drive, a system that gently adjusts the electrical frequency sent to the motor, allowing its speed to rise and fall in soft, rounded patterns rather than sharp lines. Imagine, if it helps you rest, a long hill with gentle slopes instead of sudden cliffs. That is what a variable frequency drive creates for the motor's motion, curve after curve, easing into speed and easing back out of it. This is why an elevator ride feels so calm, so steady, so free of any harsh jolt or sudden lurch. The motor is never simply switched on and never simply switched off. It is coaxed gently into motion and coaxed just as gently back into stillness. Let's slow down now and picture, in careful detail, an elevator beginning its journey from rest. The car sits quietly at the ground floor, doors closed, everything still. Somewhere above, in the machine room or hidden within the shaft, the motor controller receives a small signal, a quiet request for movement. And rather than reacting suddenly, it begins its work slowly, sending a gentle, gradually increasing current to the motor. The motor, resting until now in complete stillness, begins to turn. At first, its movement is so slow it would be difficult to notice at all, the way a large ship begins to move away from a dock, almost imperceptibly, and then slowly, undeniably. As the motor's rotation increases, so does the rotation of the sheave above the shaft, and as the sheave turns, the steel ropes draped across it begin to slide, ever so gently, along its grooves. Far below, in the cab itself, this translates into the softest possible sensation, a light rising feeling, barely more than a whisper of motion beneath your feet. The car begins to lift, not suddenly, not sharply, but with the same slow, rounded curve of acceleration that the motor itself is experiencing above. Every part of the system moves together, in careful agreement, motor and sheave and ropes and car, all rising into motion with the same unhurried grace. And on the other side of that same sheave, something else is happening at the very same moment, something quiet and important, something worth resting your attention on for a little while now. As the car rises, the counterweight lowers. As one side of the rope shortens, the other side lengthens. Up and down and up, two shapes moving in perfect quiet opposition, connected by the same steel cable, balanced against each other the way two ends of a scale might balance against each other, equal and opposite, steady and calm. Let's spend some time now, gently, thinking about this counterweight, because it plays a far more important role than its quiet, unremarkable appearance might suggest. Many elevators, especially in taller buildings, are built with a large counterweight, a heavy block, usually made of cast iron or concrete, resting on its own small platform, connected to the elevator cab by the very same ropes that pass over the sheave above. The purpose of the counterweight is simple, and yet, if you think about it slowly, quite elegant. Its weight is chosen to roughly balance the weight of the elevator cab itself, along with a portion of its typical passenger load. This means that when the motor needs to lift the car, it isn't lifting the entire weight of the cab and its passengers all on its own. Instead, much of that weight is already being balanced quietly by the counterweight resting on the other side of the rope. Picture, if it helps you rest a little more deeply, an old-fashioned set of scales, the kind with two hanging trays, one on each side. If both trays hold roughly the same weight, only a small amount of extra effort is needed to tip the balance one way or the other. The elevator works in much the same way. The counterweight sits on one side, the cab and its passengers on the other, and the motor's task becomes simply to manage the small difference between them rather than to carry the full weight all alone. This is why elevators can move so smoothly, so efficiently, using motors that are, in truth, far smaller and far gentler than you might expect for the task of lifting an entire room full of people many floors into the air. The counterweight does much of that quiet work invisibly, unnoticed, resting on the other side of the shaft, moving in careful opposition every single time the car rises or falls. And this balance brings with it another quiet benefit, one that matters a great deal, even if it's rarely thought about. Because the motor only has to manage the difference in weight between the cab and the counterweight. Rather than the cab's full weight alone, the whole system uses significantly less energy. Less effort is needed, less electricity is drawn. The building's power system barely notices the elevator's movement at all, the same way you might barely notice your own breath moving in and out as you drift closer to sleep. Let's continue picturing that same elevator, now rising steadily partway up through the shaft, and think carefully about what's happening on both sides of the rope at once. On one side, the cab moves upward, floor by floor, passing gently along its guide rails, its small position sensors quietly marking each level as it goes. On the other side, hidden further back in the shaft, often along its own separate set of guide rails, the counterweight moves downward, smoothly, steadily, matching the cab's motion in perfect, quiet opposition. If you could watch both of these things happening at once, side by side, you might notice how calm the whole scene appears. No struggle, no visible effort, just two objects, one rising, one falling, connected by movement that feels less like force and more like balance. The elevator does not move because the motor pushes hard against gravity. It moves because gravity itself has been gently, carefully arranged into equilibrium, and the motor simply nudges that equilibrium softly in whichever direction is needed. This idea is worth resting on for a moment, because it captures something true not only about elevators, but about many well-designed systems. The elevator moves not through force alone, but through balance and careful control. Force alone would be loud and effortful and rough. Balance is quiet. Balance is smooth. Balance allows a small motor to lift a heavy load without strain, the same way a well-rested mind can carry a heavy day without feeling overwhelmed, simply because the weight has been distributed evenly, simply because nothing is being carried all at once, all alone. As the cab continues rising toward its destination floor, the motor controller begins once again its quiet work of gentle adjustment. It does not wait until the very last moment to slow the car down. Instead, it begins easing the motor's speed gradually, well before the floor is reached, allowing the same soft, rounded deceleration that we felt at the very beginning of the ride. The variable frequency drive adjusts its signal once more, this time guiding the motor not toward greater speed, but gently back toward stillness. The sheave above begins to slow its rotation. The The ropes begin to move more gradually along its grooves, and far below, in the quiet cab, the sensation is almost identical to the one felt when the ride began, only reversed, a slow, gentle settling rather than a slow, gentle rise. The counterweight, too, begins to slow its own downward motion, matching the cab's deceleration precisely, the two sides of the system easing back into stillness together in the same quiet agreement they held throughout the entire journey. And then, at last, the car arrives. The motor's rotation slows to nothing. The sheave stops turning. The ropes hang still once more. And on the other side of that same rope, the counterweight too comes to rest, hanging quietly in the dark, exactly where it needs to be, exactly balanced against the cab that now sits gently at its new floor. For a moment, everything is still again. The motor rests. The controller's small lights continue their slow, steady blinking, watching, waiting, but no longer working, at least not for now. Somewhere above, in the machine room or tucked quietly within the shaft, the whole system settles back into the same patient readiness it held before the journey began, prepared, whenever needed, to repeat this same slow, careful process once more. All of this, the motor's gentle turning, the sheave's smooth rotation, the counterweight's quiet balance, happens without most passengers ever noticing any of it at all. They simply feel a soft, steady motion, up or down, and then the gentle stop, the quiet chime, the doors easing open once more. Behind that simplicity, though, rests an entire hidden choreography of careful engineering, motors and drives and ropes and counterweights, all moving together in smooth, unhurried harmony. But movement alone is not the whole story, because even the most carefully balanced system still needs a way to protect itself, a way to sense trouble before it happens, a way to slow or stop safely if anything were ever to go wrong. And so, gently, quietly, our attention will turn next toward the doors that guide us in and out, the sensors that watch continuously over every part of the journey, and the brakes that rest, patient and ready, prepared to hold everything steady, should they ever be needed at all. Let's picture now an elevator lobby late at night, empty and quiet, its floor polished to a soft shine that reflects the dim overhead lighting in long, gentle streaks. The doors themselves are still, closed, their metal surfaces cool and smooth, catching the faintest glimmer of light along their edges. Above them, a small indicator lamp glows softly, unmoving, simply marking the elevator's presence, the way a nightlight marks a hallway without needing to do anything more than exist. There is something very peaceful about a closed elevator door. It holds no urgency. It asks nothing of you. It simply waits, patient and still, prepared to open the moment it's needed, and perfectly content to remain closed until then. And yet, even in this stillness, the doors are one of the most active, most carefully engineered parts of the entire elevator system. They open and close many times throughout a single day, quietly, repeatedly, and every single time. A small, careful process unfolds behind that simple motion. Let's imagine gently someone arriving at this lobby, though of course right now, in the stillness of night, no one is here at all. But let's imagine it anyway, softly, as a way of understanding how the system moves. A hand reaches out and presses a small illuminated button. The button glows a little brighter, acknowledging the request. And somewhere else in the building, a controller receives this signal, quietly, calmly, and begins its own careful sequence of checks. Before anything moves, the controller first confirms where the car currently rests, which floor it occupies, whether it's already in motion, whether it's available to respond. This happens instantly, and yet it happens thoughtfully, the way a careful mind considers a question fully before offering an answer. Once the controller determines that the car is ready, it begins the quiet process of bringing it to the requested floor, the motor turning gently, the counterweight shifting in its own quiet balance, all of it unfolding exactly as we described a little earlier. When the car finally arrives, another small, careful sequence begins, this time focused entirely on the doors. A dedicated door operator, its own small motor separate from the main lifting machine, begins to turn. This operator connects to the doors through a system of belts or gentle mechanical arms, translating its rotation into smooth, even sideways motion. The doors do not simply spring open, they ease open, gliding gently along their tracks, guided by small rollers fitted along the top and sometimes the bottom of each panel, keeping their movement steady and precise. This happens in two places at once, worth resting your attention on for just a moment. There are actually two sets of doors involved in every elevator stop, though most people only ever think of one. There are the landing doors, fixed to the wall of each floor, the ones you see waiting in the hallway. And there are the cab doors, attached to the elevator car itself, moving along with it as it travels up and down the shaft. When the car arrives at a floor, these two sets of doors align perfectly, and a small mechanical coupling allows them to move together, opening and closing as one smooth, unified motion, even though they are, in truth, two separate sets of doors working in careful cooperation. As the doors begin to open, and later, as they begin to close, an invisible layer of protection watches quietly over the doorway. Small infrared sensors, mounted along the edges of the cab doors, send a soft, continuous beam of light across the opening, back and forth, invisible to the human eye, checking constantly for anything that might be passing through. This is sometimes called a light curtain, a gentle name for a gentle system, a soft wall of unseen light standing guard over the doorway every time it opens or closes. If this beam is ever interrupted, even briefly, even by something as small as an outstretched hand or the edge of a bag, the doors respond immediately, not with force, but with patience. They pause, they reverse, they open again, gently, giving whatever passed through a little more time, a little more space, before trying once more. There is never any urgency in this response, never any sense of frustration in the system. It simply waits, checks again, and tries again, calmly, as many times as necessary, until the doorway is finally clear. Once the doors have closed completely, another quiet safety check takes place, one that happens before the elevator is ever allowed to move again. This check involves something called a door interlock, a small mechanical and electrical device fitted to each door along the shaft. Its only purpose is to confirm, absolutely and certainly, that the doors are fully closed and securely latched. Only when every single interlock along the shaft confirms this closure does the elevator's control system allow the car to begin moving again. This is worth sitting with for a moment, softly, because it reflects something important about how these systems are built. The elevator does not assume that the doors are closed simply because a motor has finished turning. It waits for confirmation, it checks, it verifies quietly and thoroughly before allowing any further movement to happen at all. Nothing is taken for granted. Every step earns its own quiet proof before the next step is allowed to begin. All of this checking, all of this quiet verification happens through what is called a safety circuit, an electrical pathway that runs continuously throughout the entire elevator system, connecting every important safety device into one unified, watchful loop. If every single condition along this circuit is satisfied, doors closed, interlocks engaged, brakes released, speed within normal limits, only then does the circuit remain complete, allowing the system to move. But if even one condition along that circuit is not met, the circuit is interrupted, and the elevator simply will not move at all, calmly and immediately, the way a held breath simply pauses rather than continues. This is one of the quiet truths worth remembering gently as you continue to relax. The safest systems are often the ones we never notice. We don't see the safety circuit. We don't see the interlocks confirming their quiet agreement. We don't see the infrared beams stretching invisibly across the doorway. We simply experience a smooth, uneventful ride, doors closing gently, car moving steadily, doors opening again at the right floor. All of that calm simplicity is only possible because underneath it, layer after layer of quiet confirmation has already taken place. Let's move now softly toward another kind of protection, one that rests not at the doorway, but within the machine itself. Every elevator is equipped with mechanical brakes, sturdy devices built directly into the motor assembly, designed to hold the car securely in place whenever it is not actively moving. These are sometimes called holding brakes, and their purpose is wonderfully simple. When the elevator is at rest, these brakes engage automatically, gripping firmly, quietly, keeping the car exactly where it needs to be, without any drift, without any uncertainty. You might imagine these brakes the way you might imagine a hand resting gently but firmly on someone's shoulder, not gripping tightly, not restraining, simply steadying, simply reassuring, simply present. Whenever the elevator receives a new instruction to move, these same brakes release smoothly, allowing the motor to begin its own gentle acceleration, and then, once the car reaches its destination, the brakes engage once more, quietly holding everything steady until the next request arrives. Above this braking system, usually mounted near the top of the shaft, another quiet guardian watches continuously over the elevator's speed. This is called the overspeed governor, a mechanical device connected to its own separate cable that moves in direct relation to the car's motion. Its only task, its only purpose, is to observe speed gently and continuously, comparing the car's actual movement against the speed it should be traveling at any given moment. Should the car ever begin moving faster than intended, faster than what the system considers safe, this governor would respond immediately, engaging a secondary set of safety brakes built directly into the car's frame. These brakes would grip the guide rails firmly and evenly, bringing the elevator to a slow, controlled stop rather than an abrupt or jarring one. It's worth remembering gently that this entire system almost never needs to act. Across the vast majority of elevators, across countless years of daily use, this governor and its accompanying brakes may never engage even a single time. They simply wait, quietly, patiently, the way a spare key waits in a drawer, present and ready, hopeful that it will remain forever unused. Let's think, too, about what happens during moments when power itself becomes uncertain. When a building experiences a brief interruption in electricity, even here, layers of quiet protection remain in place. Emergency lighting within the cab activates automatically, powered by small backup batteries built directly into the elevator's own systems, providing soft, steady illumination even if the building's main power has paused. The car does not go dark. The space does not become disorienting. A gentle light remains, calm and constant, exactly when it's needed most. In many buildings, additional backup systems allow the elevator to complete a small, careful motion even during a power interruption, easing gently to the nearest available floor, opening its doors calmly, allowing anyone inside to step out into a lit hallway rather than remaining still in an unlit space. This isn't a dramatic rescue. It isn't an alarm or a sudden event. It's simply another quiet layer of preparation, another patient system that has been waiting, unnoticed, for a moment that may never come. And near the control panel inside the cab, tucked quietly beside the floor buttons, rests the small emergency communication system we mentioned earlier, a soft, simple connection to someone on the other end, awake and listening, even in the stillness of late-night hours. It exists not to create worry, but to remove it, a quiet reassurance that even in the rare moments something feels uncertain, a calm voice remains only a few words away. All of these systems, the interlocks, the light curtains, the safety circuits, the holding brakes, the overspeed governor, the emergency lighting, the backup communication, none of them work entirely alone. They exist together, layered gently over one another, each one quietly reinforcing the others, so that no single system carries the full weight of safety by itself. This is sometimes called redundancy, a word that simply means more than one system is watching, more than one layer is prepared, more than one quiet guardian stands ready, just in case. There is something deeply comforting in that idea if you let yourself rest in it for a moment. Nothing here depends on just one thing going right. Everything is layered, softly, one protection resting behind another and another behind that. Even if one system paused, even if one sensor hesitated, others remain in place, quietly continuing their watch, exactly the way many good systems in life are built, not on a single point of strength, but on many small, patient layers working gently together. Let's return once more to that quiet person we imagined earlier, standing in the empty lobby, pressing the call button, waiting patiently as the elevator approaches. The doors ease open smoothly, checked and confirmed. The person steps inside, and the doors begin their gentle closing motion, sensors quietly watching the doorway the entire time. Once closed, the interlocks confirm their agreement, the safety circuit completes its quiet loop, the holding brakes release, and the motor begins its familiar gentle turn. The elevator moves, steady, smooth, unremarkable, exactly as it should be. And underneath that simplicity, every single one of these quiet systems has already done its part, checking, confirming, watching, holding, releasing, all without a single visible sign of effort, all without a single moment of urgency. None of this happens by accident. None of this happens without coordination. Somewhere within the building, a quiet, watchful intelligence oversees the entire process, gathering signals, making decisions, coordinating each of these systems into one smooth, continuous rhythm. And it's there, gently, that we'll turn our attention next, toward the elevator controller itself, the calm, unseen mind that listens to every request, checks every condition, and guides the whole system quietly and patiently from one still moment to the next. Let's move now, quietly, into a small room tucked somewhere near the top of the building, or perhaps hidden within a compact equipment space built directly into the shaft. This room holds no windows, no furniture, nothing but rows of metal cabinets standing in careful, orderly lines, each one humming so softly that the sound barely registers at all. Small lights blink along their surfaces, some steady, some pulsing gently, some so faint they seem to breathe rather than shine. This is the control room, though in many buildings it's simply a single tall cabinet standing alone in a quiet corner. And it's here, in this unremarkable space, that the true intelligence of the elevator system quietly resides. We've spoken already about motors and counterweights, about doors and brakes, about all the careful mechanical pieces that allow an elevator to rise and fall so smoothly. But none of these pieces would know what to do or when to do it without something to guide them. That guidance comes from the controller, a small, patient system that never stops paying attention, never stops listening, never fully rests, even in the quietest hours of the night. Think of the controller as something like the nervous system of the building, though of course much smaller, much quieter, much more contained. Just as your own body is filled with signals traveling gently between your mind and your muscles, your senses and your thoughts, the elevator system is filled with countless small signals traveling constantly between buttons, sensors, motors, and doors. And the controller sits at the center of all of it, receiving these signals, considering them, and responding with calm, measured decisions. Throughout a single day, in a busy building, this controller might process thousands of small decisions, one after another, each one so brief, so effortless, that it passes almost instantly. And yet, even at this quiet hour, long after the last occupant has gone home, the controller remains awake, not thinking, not exactly, but watching, continuously aware of where the elevator car rests, continuously aware of its own systems, continuously prepared should a single request arrive. Let's think slowly about how the controller always knows exactly where the elevator car is resting within the shaft. We spoke earlier about the small position sensors placed along the height of the shaft, quiet markers spaced evenly at each floor. As the car moves past these markers, whether rising or falling, they send a small, steady stream of signals back to the controller, confirming the car's position again and again, floor by floor, almost like a soft, repeated whisper. Yes, here. Yes, here. Yes, here. This constant tracking allows something that might otherwise seem difficult: the ability to stop the car so precisely that its floor lines up perfectly with the floor of the building, without a single visible gap, without the smallest uneven step. The controller doesn't simply guess when to slow the motor. It knows, continuously, exactly how far the car has traveled, and exactly how much further it needs to go, adjusting its instructions gently and precisely as the car approaches its destination. Let's imagine softly someone approaching an elevator lobby, though of course at this late hour the halls remain empty and still. But let's picture it anyway, gently, as a way of understanding the full journey a single request takes. A hand reaches toward a small illuminated button on the wall, one for going up, another for going down, and presses it softly. The button responds instantly, its light glowing a little brighter, confirming that its signal has been received. That small press becomes something more than just a physical motion. It becomes information. An electrical signal travels quietly through hidden wiring, out from the button, through the walls, down through conduits threaded carefully behind plaster and paint, until it arrives, a moment later, at the controller itself. This entire journey, from finger to button to wire to controller, happens in a fraction of a second, so quickly that the person waiting never notices any delay at all. Once the controller receives this signal, it begins its own quiet process of consideration. In a building with only one elevator, this process is simple, almost immediate. But in many buildings, especially larger ones, multiple elevators may share the same lobby, and the controller must decide gently and efficiently which car should respond to this particular request. It considers each elevator's current position, the direction it happens to be traveling, whether it's already carrying passengers, and how quickly it could reasonably arrive. All of this happens in near silence, unseen calculations moving quietly through the system, weighing small pieces of information the way a careful mind might weigh several quiet thoughts before settling gently on one. Once a decision is made, another simple confirmation appears. A small indicator light near the button glows softly, letting anyone waiting know that their request has been received and that an elevator is already on its way. There's something reassuring in that small glow, isn't there? A quiet acknowledgement, a silent promise that somewhere above or below, machinery is already responding, already beginning its long, smooth journey. Inside the responding elevator, the controller now sends its instructions onward, first to the motor controller we spoke of earlier, gently increasing the current sent to the motor, allowing it to begin its familiar, smooth acceleration. As the car approaches its destination floor, the controller once again draws upon its continuous awareness of position, easing the motor's speed gradually, allowing that same soft, rounded deceleration we've described before. And once the car finally arrives, level and steady, the controller signals the doors to begin their gentle opening motion, only after confirming, quietly and thoroughly, that it is safe to do so. All of this, from the very first press of a button to the final gentle opening of the doors, happens through a continuous, unseen conversation, small signals passing back and forth between components, each one confirming, checking, and responding to the others. It's a quiet kind of communication, nothing at all like human conversation, and yet, in its own way, remarkably similar. A request is made, it's received, it's considered, a response is given, and throughout it all, everything remains calm, orderly, and clear. Let's think too about the small buttons found inside the cab itself, the panel of glowing numbers that passengers press once they've stepped inside. These buttons work in much the same way as the ones found in the lobby, sending their own small signals to the controller, requesting a particular floor. The controller receives each of these requests and organizes them thoughtfully, often grouping nearby floors together so that the elevator's journey remains efficient, smooth, and unhurried, rather than doubling back unnecessarily or repeating unnecessary stops. Above the doors, both inside the cab and often in the hallway beyond, small displays glow softly, showing the current floor and the direction of travel, gentle visual confirmations of everything the controller already knows internally. In many buildings, this same system also coordinates soft voice announcements, a calm, recorded voice quietly confirming each floor as it's reached, or gently reminding passengers which direction the car is currently traveling. All of this, the lights, the displays, the voice, works together seamlessly, coordinated by the same quiet controller resting patiently in its cabinet. It's worth pausing here for a moment, gently, to consider just how much hidden technology supports even the simplest of passenger interactions. Someone steps into an elevator, presses a single button, and waits. That's all they experience. That's all they need to experience. And yet, behind that simplicity, an entire quiet system has been listening, calculating, coordinating, and responding continuously, invisibly, patiently. Even now, in this late, still hour with no passengers anywhere in the building, the controller remains exactly this attentive. It continues monitoring its own internal systems, checking that its sensors remain functional, that its communication pathways remain clear, that everything continues resting in a state of quiet readiness. Small lights on its control cabinet blink slowly, steadily, confirming again and again that all is well, that nothing needs attention, that everything remains simply prepared. The elevator is always listening, always aware, and always ready, whether or not anyone happens to be nearby to notice. Let's imagine one more time this quiet controller resting in its cabinet, somewhere above the shaft, its small lights glowing softly in an otherwise dark and silent room. Nothing is happening right now. No buttons are being pressed, no cars are moving, and yet the system remains awake in its own gentle way. Its circuits quietly powered, its sensors quietly alert, ready to spring into its familiar careful sequence the very moment someone somewhere reaches out and presses a button. This kind of quiet readiness is worth resting on for a while, because it reflects something calming about well-designed systems in general. They do not need to be constantly active to be reliable. They simply need to remain aware, patient, and prepared, resting quietly until they're needed, and then responding smoothly and confidently when the moment finally arrives. The elevator controller lives almost entirely in this state, more waiting than doing, more listening than acting, and yet entirely essential to everything the elevator accomplishes. In smaller buildings, this single controller manages everything: one elevator, one set of doors, one shaft, one set of decisions to make. But in larger buildings, especially very tall towers with many floors and many occupants, a single elevator is rarely enough. Several elevators often share the same building, sometimes several within the very same lobby, all waiting quietly side by side, all prepared to respond to the same rush of morning requests or the same quiet trickle of late-night ones. And when multiple elevators share a single building, a new kind of coordination becomes necessary, something a little more complex than the simple singular awareness we've been describing so far. Multiple cars must be tracked at once. Multiple requests must be organized efficiently so that passengers aren't left waiting unnecessarily, and so that no single elevator becomes overburdened while others stand empty and idle nearby. This requires a broader kind of intelligence, a system capable of watching over an entire group of elevators at the same time, coordinating their movements the way a calm, careful conductor might coordinate many quiet instruments within a single, unhurried piece of music. And it's there, gently, that we'll turn our attention next, toward the way larger buildings manage not just one elevator, but many, working together in careful harmony, each one aware not only of itself, but of the others resting quietly nearby, all guided by systems built to keep an entire tower moving smoothly, quietly, and reliably, floor after floor, night after night. Let's picture now a tall building rising quietly into the night sky, its upper floors glowing faintly against the darkness, most windows unlit, a few scattered here and there like the last embers of a fire settling down for the night. Somewhere far below, at street level, a wide lobby stretches out beneath soft, even lighting, its floors polished and still, its air calm and undisturbed. And along one wall, a whole bank of elevator doors waits patiently, evenly spaced, each one closed, each one quiet, each one part of something larger than itself. We've spent some time now thinking about a single elevator, its motor, its counterweight, its doors, its careful controller listening quietly for the next request. But in buildings like this one, tall and busy and filled with many floors, a single elevator is rarely enough. Instead, several elevators often work together, side by side, sharing the same lobby, sharing the same general purpose, and yet coordinated by something a little broader than any one of them alone. This is sometimes called an elevator bank or an elevator group, and it behaves in many ways like a single connected transportation system, even though it's made up of several separate cars. Let's think slowly about how this kind of coordination might work in a very busy building, one filled with many offices, many residents, many people moving throughout the day. In simpler systems, each elevator waits for a call button to be pressed, and the controller decides gently which car should respond. But in some modern buildings, a more advanced approach is used, something called a destination dispatch system, a quiet, thoughtful method of organizing passengers even before they step inside a car at all. Picture a small kiosk standing near the elevator lobby, its screen glowing softly, waiting patiently for someone to approach. Instead of simply pressing an up or down button, a person entering this lobby might gently touch a screen indicating the exact floor they wish to reach. The system considers this request quietly, and rather than simply sending the nearest elevator, it thinks a little further ahead. It looks at who else is currently waiting and where they hope to go, and it begins grouping passengers together, gently gathering those traveling to nearby floors into the very same car. This means that once inside, a person may find that everyone around them is heading toward a similar destination, a shared handful of floors clustered closely together, rather than a car stopping at every single level along its journey. Fewer stops, fewer pauses, a smoother, more continuous rise from lobby to destination. It's a quiet kind of thoughtfulness, really, software quietly organizing the small, scattered wishes of many different people into one smooth, shared journey. This same software continues its careful work throughout the entire day, watching gently how the building moves. Mornings often bring a very different rhythm than evenings. In the early hours, many people arrive together, moving from the lobby upward, all beginning their day at nearly the same moment. In the evening, that pattern often reverses, people trickling down from many different floors, gathering again in the lobby, ready to step back out into the quiet evening air. The system studies this rhythm quietly, day after day, learning the particular pulse of this particular building, adjusting its own behavior gradually to match it. You might imagine this software the way you might imagine someone who has lived in the same house for many years, someone who instinctively knows when the mail arrives, when the light changes in late afternoon, when the house grows quiet in the evening. The elevator system develops a similar quiet familiarity with its building, learning its patterns, anticipating its rhythms, adjusting itself gently based on patterns it has seen unfold many times before. Let's rise a little further now, gently, and think about very tall buildings, the kind that stretch many dozens of floors into the sky. In buildings this tall, a single elevator bank often isn't practical. Instead, the building is divided into sections, sometimes called low-rise, mid-rise, and high-rise zones, each one served by its own dedicated group of elevators. A person heading to one of the lower floors might use elevators that never travel above a certain level, while someone heading much higher might need to transfer partway up, stepping from one elevator into another at a place sometimes called a sky lobby, a smaller, quieter version of the ground floor lobby, suspended high above the street, resting gently within the building's upper structure. In some very tall towers, certain elevators are designated as express elevators, cars built to travel long distances without stopping at all, rising swiftly and smoothly past dozens of floors before finally slowing gently as they approach their designated section. This allows the whole system to remain efficient, even across enormous vertical distances, balancing speed and comfort carefully, so that even a very long journey still feels smooth, still feels calm, still feels unhurried despite covering so much height. All of these separate groups, low-rise and mid-rise and high-rise, express and local, still remain connected through the same underlying philosophy we've been returning to throughout this journey. Each elevator knows its own position. Each elevator communicates quietly with the others nearby. And a broader system, somewhere within the building's control infrastructure, watches over all of them together, coordinating their movement the way a calm conductor might coordinate many quiet instruments, each playing its own small part, together forming something more organized than any single part could achieve alone. Let's imagine softly this same tall building late at night, the very same hour we began our journey in so many chunks ago. Picture its many elevator cars, scattered now throughout the height of the structure, resting quietly on different floors rather than gathered together at the lobby. This is intentional. Even in stillness, the system remains thoughtful, positioning its cars gently throughout the building, so that whenever the first request of the morning arrives, an elevator is already reasonably close by, ready to respond quickly and calmly, rather than needing to travel a great distance from a single resting point. This is another quiet example of preparation happening before it's ever needed. The building doesn't wait until morning traffic begins to think about efficiency. It has already, quietly, throughout the night, positioned its resources thoughtfully, the way someone might lay out clothes the night before an early morning, not because it's urgent, but because it's calm and considerate preparation, offered gently to a future moment that hasn't in effect arrived yet. Let's turn our attention now, gently, toward another quiet capability built into these systems, one that connects elevators to the broader safety infrastructure of the building itself. This part deserves the same calm, unhurried tone we've held throughout, because even here, in systems designed for unusual circumstances, The underlying feeling remains one of preparation and coordination rather than urgency or alarm. Every elevator system includes a special mode of operation designed for use during a fire alarm condition, sometimes called fire service operation. This mode exists quietly within the system at all times, resting unused through the vast majority of the building's life, much like the safety brakes and buffers we described earlier, present simply as a form of careful preparation. Should a fire alarm ever activate within the building, the elevator system responds automatically in a process sometimes called elevator recall. Rather than continuing to respond to ordinary passenger requests, the elevators are guided instead toward a single predetermined floor, usually the ground level, or in certain situations, an alternate designated floor if smoke or other conditions make the ground level unsuitable. Doors remain open at this recall floor, cars sitting quietly, no longer responding to calls from other levels. This recall happens through a quiet, direct connection between the fire alarm system and the elevator controller, two separate building systems speaking gently to one another, coordinating their response the moment unusual conditions are detected. Smoke detectors placed near elevator lobbies play a small role in this process as well, helping the system determine which floors remain suitable for elevator operation and which floors should be avoided. Once elevators have been safely recalled, a secondary mode becomes available, one intended specifically for use by trained emergency responders. Sometimes called firefighter operation, this mode allows a firefighter, once inside the cab, to take manual control of the elevator's movement, traveling between floors deliberately and carefully, guided by their own judgment rather than the ordinary automated system. This gives emergency personnel a controlled, reliable way to reach different levels of the building quickly, while ordinary passenger use remains gently paused during this time. Supporting all of this quietly is the building's emergency power system, the same kind of backup infrastructure we spoke gently about earlier, resting unused through ordinary operation, but capable of stepping in should regular power become interrupted. In many buildings, this backup power is specifically designed to support at least one or two designated elevators, ensuring that even during a power interruption, a way to move safely between floors remains available. None of this needs to feel dramatic or urgent, even as we describe it now. It's simply another layer of quiet preparation, another example of different building systems, the elevators, the fire alarms, the emergency power, all speaking softly to one another, coordinating gently so that even unusual moments are met with calm, practiced readiness rather than confusion. Much like the building automation systems we've explored in other quiet corners of this channel, or the fire alarm systems resting watchfully throughout a structure's walls, the elevator system doesn't exist entirely on its own. It exists as one thoughtful piece within a much larger, quietly coordinated whole, every system aware, in its own gentle way, of the others resting nearby. And so, as this tall building continues to rest through the night, its elevators positioned thoughtfully throughout its height, its fire systems quietly monitoring, its emergency power resting in patient readiness, everything remains calm, prepared, and connected, layer upon layer of quiet coordination, working together without ever needing to announce itself. As we drift now toward the final part of our journey together tonight, Let's think gently about what happens to all of this machinery once the building has fully settled into its overnight stillness. Because even now, even in this quiet, unmoving hour, elevators are not simply switched off and forgotten. Somewhere, quiet monitoring continues. Somewhere, small systems record and observe, watching gently over motors and cables and doors, preparing carefully for the maintenance that keeps everything running smoothly, year after year, night after night. And it's there, in that soft, steady overnight rhythm, that we'll rest for the remainder of our time together, drifting gently towards sleep alongside the elevators themselves, patient, watchful, and calm. Let's think now, softly, about what happens to an elevator long after it has finished carrying its last passenger of the day, long after the buttons have stopped glowing with fresh requests, long after the doors have closed for what may be the final time until morning. Because even in this quiet aftermath, even in this long stretch of stillness that follows a busy day, the elevator does not simply disappear from awareness. It continues in its own gentle way to be watched, to be measured, to be gently cared for, even when no one is thinking about it at all. Every time an elevator moves, whether carrying a single quiet passenger or an entire small crowd, it quietly records small pieces of information about itself. How long did the motor take to reach full speed? How smoothly did the deceleration happen? Did the doors open and close within their expected time? Did every sensor along the way report exactly what it should have reported? All of this becomes a small, steady stream of data, gathered continuously, softly, without any fanfare, simply another quiet layer of attentiveness built into the system. This information doesn't vanish once it's collected. In many buildings, it travels onward, gently, through a network connection, to a monitoring system that may not even be located within the building at all. Somewhere else, perhaps miles away, in an office that itself may be dark and empty at this very hour, a computer quietly receives this information and stores it, patiently, the way a diary might hold the small details of many ordinary days, waiting for someone, eventually, to read back through them. This is sometimes called remote monitoring, and it exists for a very calm, very practical reason. By watching these small details closely over time, patterns can be noticed long before they ever become anything worth worrying about. A door that takes a fraction of a second longer to close than it once did. A motor that draws a slightly different amount of current than it used to. A ride that feels, according to its own sensors, very slightly less smooth than the thousands of rides that came before it. None of these small changes mean anything is wrong, not yet, not necessarily ever, but they are noticed gently and remembered, so that if a true pattern does begin to form, it can be addressed calmly and early, long before it would ever be noticeable to someone simply riding inside the car. This is sometimes referred to as predictive maintenance, a phrase that sounds more complicated than the idea truly is. It simply means paying quiet attention over a long period of time, rather than waiting for something to become obvious before responding to it. It's a little like noticing gently that a favorite chair has begun to creak slightly more than it used to, and choosing to tighten its joints before it ever becomes uncomfortable to sit in, rather than waiting for it to break beneath you. The elevator system practices this same kind of quiet foresight, continuously, patiently, day after day, night after night. Technicians, real people with careful hands and calm attention, review this gathered information regularly, sometimes checking in remotely, sometimes visiting the building itself to walk slowly through machine rooms and shaft spaces, listening, watching, feeling for anything that might benefit from a small adjustment. They might tighten a cable slightly, or apply a little more lubrication to a guide rail, or recalibrate a sensor so that its readings remain perfectly precise. These are rarely dramatic repairs. They are usually small, quiet corrections, the kind of steady care that allows something to keep working smoothly for a very long time. And elevators, when cared for in this steady, attentive way, can continue operating for many decades. The same motor, the same sheave, the same counterweight, moving gently through the same shaft, year after year, generation after generation of passengers stepping in and out, most of them never once thinking about the quiet machinery carrying them. This kind of long reliability doesn't happen by chance. It happens because of this ongoing rhythm of gentle attention, small adjustments made regularly, small pieces of data gathered continuously, small moments of care offered again and again, so quietly that they almost blend into the background of the building's ordinary life. Let's imagine now, very slowly, a technician walking through a machine room much like the one we visited earlier in our journey tonight. The room is quiet, lit by a single overhead light, humming faintly along with the resting motor nearby. The technician moves unhurriedly, checking a gauge here, listening for a moment there, occasionally jotting something down, or perhaps simply confirming quietly that everything remains exactly as it should be. There's no urgency in these visits. They happen on a calm, steady schedule, regular and expected, much like a doctor's routine visit rather than an emergency call. Just careful, ongoing attention, offered patiently, again and again, to a system that mostly, quietly, takes care of itself. Let's drift now, gently, back toward the building itself, and toward this particular hour, the deep, still hour of night that we've been returning to throughout our time together tonight. Let's imagine, one more time, the very last person leaving this building for the evening. Perhaps someone finishing a late project, gathering their things slowly, turning off a desk lamp, walking softly down a quiet hallway toward the elevator lobby. They press the call button, and somewhere above or below, an elevator begins its familiar journey, arriving smoothly, doors easing open just as they always do. This person steps inside, presses a button for the ground floor, and the car begins its long, gentle descent, one final ordinary journey before the building settles fully into its overnight stillness. The doors open one last time at the lobby. This person steps out into the quiet night air, and behind them, the doors close softly, gently, the same unhurried motion they've performed thousands of times already today. And now, at last, the building is truly empty. The lobby, once filled with the small sounds of footsteps and quiet conversation, becomes completely still. The overhead lighting, sensing this stillness, gradually dims itself down, the way it often does in the later hours, lowering gently into a soft, low glow, enough to see by, but no more than that. And somewhere within the elevator system, the controller notices, in its own quiet way, that no further requests have arrived for quite some time now. It doesn't need to be told the building is empty. It simply continues doing what it always does, waiting, watching, listening softly for whatever might come next. Each elevator car settles into what might be called a standby position, resting quietly at a floor determined thoughtfully by the system itself, positioned in a way that keeps it reasonably prepared for whatever the earliest hours of tomorrow might bring. The doors remain closed. The small lights inside each car continue to glow softly, low and steady, illuminating an empty space that no one is currently occupying, and yet remains lit all the same, patient and ready, the way a porch light might stay on through the night, waiting for someone who has not yet arrived. If you could stand quietly in one of these empty cars right now, you would find it very peaceful. The soft overhead light, the faint reflection of that light in the polished walls, the gentle stillness of a room built for motion and yet for now completely at rest. No sound at all, except perhaps the faintest hum somewhere far above, the machine room continuing its own quiet watch, or perhaps nothing at all, simply silence, simply stillness, simply a small space patiently waiting for morning. High above, in the machine room, or within the compact equipment spaces built into the shaft, the motor rests exactly as still as the car it once lifted so many times throughout the day. Its surface has cooled slightly since its last movement. The sheave sits motionless, the steel ropes hanging in quiet, unmoving lines down through the shaft. And yet, nearby, the control cabinet continues its own soft rhythm, small lights blinking slowly and steadily, confirming again and again in its own quiet language that all systems remain exactly as they should be. This is worth resting on gently for a little while because it captures something calming about the entire idea of readiness. Even when nothing appears to be happening, the system is still quietly working. The controller is still monitoring. The sensors are still watching. The safety circuits are still confirming their steady agreement, position by position, condition by condition. Nothing is asleep in the way a person sleeps, and yet nothing is straining or laboring or working hard either. It exists instead in this gentle middle state, aware but calm, present but still, the way your own mind might feel right now, drifting quietly toward rest, aware of the world around you, and yet no longer needing to actively engage with any of it. Let's think, too, about how this quiet elevator system connects gently to the other quiet systems resting throughout the same sleeping building, the ones we've explored together on other nights, in other episodes of this same slow journey. Somewhere within the walls, the building's electrical system continues its own steady work, providing the small continuous current that keeps the elevator's lights glowing, its sensors alert, its controller quietly powered through the night. Without this steady electrical presence, none of the elevator's patient watchfulness would be possible at all. It rests on that quiet foundation, the same way a sleeping body rests on the steady, unnoticed rhythm of its own breathing. Nearby, the building's heating and cooling system, its HVAC, continues its own gentle work as well, keeping the machine room at a stable, comfortable temperature, ensuring the motor and its components remain within the careful range they were designed to operate within. This, too, happens without any drama, simply a steady flow of conditioned air moving quietly through hidden ducts, keeping everything calm and stable night after night. And elsewhere, the fire alarm system continues its own soft vigil, its sensors resting quietly throughout the building's many floors, prepared, should anything unusual occur, to communicate gently with the elevator controller, guiding it through the careful recall process we spoke about earlier. Beside it, the building's emergency power system waits in its own patient readiness, resting unused through most nights, and yet fully prepared, should it ever be needed, to support the elevator's continued operation, even through an interruption in ordinary power. All of these systems, elevators and electrical wiring and heating and cooling and fire alarms and emergency power, exist together within something larger still, sometimes called a building automation system, a broader, quieter intelligence that oversees many separate systems at once, allowing them all to work together smoothly, coordinated gently, like many quiet instruments resting together in the same still orchestra, none of them playing right now, and yet all of them tuned, all of them ready, all of them prepared to begin again the moment morning arrives. Let's imagine softly this entire building from a distance now, glowing gently against the night sky, most of its windows dark, a few scattered lights remaining here and there, perhaps a hallway, perhaps a stairwell, perhaps the soft glow of an elevator lobby resting quietly behind reflective glass doors. Somewhere within this tall, dark shape, dozens of quiet systems continue their patient work, unseen, unnoticed, entirely unremarkable to anyone passing by outside. And among them, resting in their shafts throughout the height of the building, the elevators wait. Let's return, one final time tonight, to the full, gentle picture of everything an elevator truly is. A motor, resting quietly above or beside the shaft, prepared to turn smoothly the moment it's asked to. A sheave, grooved carefully, holding steel ropes that stretch down through the darkness. A counterweight, hanging in perfect, patient balance, prepared to lower gently the very moment the car begins to rise. Guide rails, running straight and true along the height of the shaft, offering a path already decided, already safe. Sensors, placed carefully at each floor, softly marking the car's position again and again. Doors, both at the landing and within the cab itself, prepared to glide open and closed with smooth, cushioned motion. Infrared beams, invisible and watchful, resting gently across each doorway. Interlocks, confirming closure before movement is ever allowed. Brakes, holding everything steady the moment stillness returns. An overspeed governor, watching quietly over the car's motion, hopeful that it will never need to act. A controller, listening constantly, deciding gently, coordinating every small piece into one smooth, continuous rhythm. And beyond a single elevator, entire groups of cars, working together as one connected system, learning the patterns of the building they serve, positioning themselves thoughtfully throughout the day and through the night, prepared for whatever rhythm tomorrow might bring. All of this, every single part, working together continuously, quietly, patiently, mostly unnoticed, exactly as the best systems often are. Nothing about an elevator asks for attention. It simply performs its quiet work over and over, day after day, night after night, carrying people gently between floors, and then resting, fully prepared, the moment that work is finished, until it's needed once again. Somewhere outside, the night continues to deepen. The city grows even quieter than before. And within this tall, sleeping building, nothing changes very much at all. The elevators remain exactly where they were left, doors closed, lights glowing softly, motors cool and still, counterweights hanging in their same patient balance. The controller continues its slow, steady blinking, small lights confirming, again and again, that everything remains exactly as it should be. Sensors continue their quiet watch. Data continues gathering gently in the background, small pieces of information recorded softly, waiting to be reviewed sometime later by a technician who is, right now, very likely also asleep, resting just as peacefully as the building they help to care for. And so, as we come to the end of our long, slow journey together tonight, let's simply rest for a while in this picture. A quiet skyscraper standing tall against a dark sky. Its elevators waiting patiently behind closed doors throughout every floor. Small lights glowing softly in empty cars that no one currently occupies. Machine rooms humming faintly, motors cool, cables still. Controllers watching quietly, endlessly patient. Never quite asleep, and yet never straining either. All of it simply waiting, gently, for the first light of morning, for the first quiet footsteps returning to the lobby, for the first soft press of a button that will begin this entire graceful process once again. Until then, everything remains still. Everything remains ready. Everything remains held gently in that same quiet balance we spoke of earlier. The cab and the counterweight, the motor and the brake, the sensor and the signal, all resting together in patient, careful equilibrium. Exactly the way you might rest now, breathing slowly, thoughts settling gently. Nothing left to do, nothing left to decide, simply held, simply quiet, simply ready for whatever tomorrow will gently bring. Sleep now, if you haven't already. The elevators will keep watching through the night so you don't have to. Somewhere above you, or below you, or perhaps simply in your imagination now, a small indicator light continues its slow, steady glow, patient and unhurried, marking nothing more than the quiet passage of time, until eventually, gently, morning arrives, and the whole soft rhythm begins again. Let's settle in now, one more time, and imagine a single elevator ride, from beginning to end, slowly, gently, the way you might watch a single leaf drift down from a branch, unhurried, complete in itself, worth watching all the way to the ground. The building is quiet at this hour. The lobby stretches out beneath soft, low lighting, the kind that seems to exist only to reassure rather than to illuminate. The floors are polished and still, catching faint reflections of the ceiling lights in long, soft streaks. Along one wall, the elevator doors wait, closed and calm, their metal surfaces cool to the touch, though of course, right now, no one is touching them at all. A single person walks slowly into this lobby. Perhaps they've just come in from outside, the night air still lingering faintly on their coat. Perhaps they've been working late, moving quietly through empty hallways to reach this point. It doesn't matter really where they've come from. What matters for now is simply this. They approach the elevator and they reach out gently and press the call button. Let's slow down here, right at this very first moment, because so much is about to happen, quietly, invisibly, in the space of just a few seconds, and it's worth watching all of it unfold with patience. The button itself is a small, simple thing, a soft plastic surface lit from within by a faint glow. When the fingertip presses against it, the button does not simply light up on its own. Beneath its surface, a small switch closes, allowing a tiny electrical current to complete its path. This is the very beginning of the entire journey. This one small, quiet closing of a circuit, no different in principle from countless other small circuits that complete themselves throughout the building every day. And yet, in this particular moment, entirely its own event, entirely its own beginning. That small current does not stay where it began. It travels immediately along a wire hidden behind the wall, tracing a path that was laid carefully during the building's construction, threading upward or sideways through conduits, past insulation, behind panels, unseen by anyone, unnoticed by everyone, simply moving steadily and quietly toward its destination. Its destination is the controller, that same quiet, patient system we've spent so much time with tonight, resting in its cabinet somewhere within the building, its small indicator lights blinking slowly in the dark. The signal arrives there in a fraction of a second, so quickly that no perceptible time passes at all between the press of a finger and the controller's awareness of that press. And yet, even in that brief instant, an entire process begins. The controller receives this signal the way a calm mind receives a single clear thought. It does not react suddenly. It does not hurry. It simply acknowledges quietly that a request has arrived, this button, at this floor, waiting. And now the controller begins its own soft moment of consideration. Where is the elevator car right now? Is it resting at this very floor already? Or does it wait somewhere else in the shaft, higher up or lower down? Is it currently in motion, perhaps already responding to another request? Or is it still calm, available? All of this information already lives quietly within the controller's awareness, gathered continuously from the small position sensors placed along the height of the shaft, each one reporting again and again, softly, "This is where the car is, this is where the car is," an ongoing whisper of location that never truly stops. Let's imagine for this particular journey that the elevator car rests several floors above the lobby, still and quiet, its doors closed, its small interior light glowing softly over an empty room. The controller, having confirmed this position, now makes its gentle decision. This car, this one, will respond. But before anything moves, before the motor receives even the faintest instruction to turn, the controller pauses, quietly, to confirm something else entirely. It checks the safety circuit, that continuous, ever-watchful pathway that stretches through every important safety device in the entire system. Are the doors of the car fully closed? Yes, softly confirmed. Are the interlocks along the shaft properly engaged? Yes, gently confirmed. Is the governor reporting a safe and steady state, nothing unusual, nothing out of place? Yes, quietly confirmed. Every single condition checked, every single answer received, all within moments, all without the smallest visible sign of effort. Only once every condition has been calmly verified does the controller finally send its instruction onward toward the machine itself. High above the lobby, in the machine room, or perhaps within a compact equipment space tucked into the shaft, the motor controller receives this instruction and begins its own quiet response. First, the holding brake, that patient device that has been gripping the motor shaft firmly ever since the car last came to rest, begins to release. This release does not happen suddenly. It happens smoothly, gradually, the brake easing its hold in careful coordination with the motor's own gentle beginning of movement, so that the car never experiences even the faintest jolt as stillness gives way to motion. At the very same moment, the variable frequency drive begins its own careful work, sending a slowly increasing electrical signal to the motor, coaxing it gently out of stillness. The motor does not leap into motion. It eases into it, the way a swing might ease into its first slow arc after a gentle push, a smooth, rounded beginning rather than any sudden start. As the motor begins to turn, the sheave above the shaft turns with it, its grooved surface rotating slowly at first, then a little more steadily, drawing the steel ropes gently along with it. On one side of this rotation, the ropes begin to shorten, pulling the elevator car downward toward the waiting passenger in the lobby below. On the other side, the ropes lengthen, allowing the counterweight to rise smoothly and steadily in perfect quiet opposition to the car's own downward path. Let's picture this counterweight for a moment, resting in its own portion of the shaft, moving along its own guide rails, rising now, gently, as the car descends. Two shapes, connected invisibly by the same length of cable, moving in careful balance, one always compensating for the other, neither one straining, neither one struggling, simply exchanging position quietly, calmly, the way two ends of a scale settle gently when a small weight shifts between them. Inside the elevator car itself, this entire beginning would feel like almost nothing at all. A faint softening beneath the feet, barely more than a whisper of motion as the car begins its slow, smooth descent through the shaft. If someone were standing inside right now, and no one is, they might barely notice the moment movement began at all. So gentle is the transition from stillness into motion. As the car continues downward, floor by floor, those small position sensors we spoke of earlier continue their quiet, repeated confirmation. Each time the car passes one of these markers, a small signal returns to the controller softly noting, "Here now, here now, here now," an ongoing gentle stream of awareness that never once pauses throughout the entire journey. The controller does not need to guess where the car is at any given moment. It simply knows, continuously, precisely, through this steady rhythm of small confirmations arriving one after another. This constant awareness becomes especially important now as the car begins to approach its destination floor, the lobby where our quiet passenger continues to wait. Well before the car reaches this floor, the controller begins its next gentle instruction, guiding the motor controller to begin easing the current sent to the motor, allowing its rotation to slow gradually, smoothly, in the same soft, rounded curve that marked its acceleration only moments before. The sheave's rotation begins to slow. The ropes begin to move more gradually along its grooves, and on the other side of that same rope, the counterweight too begins to ease its own rising motion, matching the car's deceleration precisely, the two sides of the system settling back towards stillness together, in the same quiet agreement they've held throughout the entire journey. Inside the car, this deceleration feels like little more than a gentle settling, a soft easing beneath the feet, the reverse of that earlier soft rising sensation, calm and unhurried, nothing sudden, nothing abrupt. As the car draws nearer still, within just the last few inches of its approach, another small, careful process begins, one that ensures the car comes to rest not merely near the lobby floor, but precisely level with it, without the smallest gap, without the faintest uneven step. This is sometimes handled by a dedicated leveling sensor, a device built specifically to fine-tune this very final portion of the journey, making tiny, almost imperceptible adjustments to the car's position until its floor lines up exactly, perfectly, with the floor of the building beyond the doors. And then, at last, the car comes to rest. The motor's rotation stops completely. The holding brake engages once more, firm and steady, gently securing the car in its new position. The counterweight, too, settles into its own matching stillness, hanging quietly on the other side of the shaft, perfectly balanced against the car that now waits, patient and still, at the lobby floor. Before the doors are permitted to open, the controller performs one more quiet check, confirming that the car has indeed come to rest precisely at floor level, confirming that all safety conditions remain satisfied, confirming gently and thoroughly that everything is exactly as it should be before allowing the next stage of the journey to begin. Only then does the instruction to open finally arrive at the door operator, that small dedicated motor built solely for this purpose. It begins to turn smoothly and evenly, drawing the cab doors open along their tracks and through the small mechanical coupling we spoke of earlier, drawing the landing doors open in perfect unison, the two separate sets of doors moving together as though they were only ever one. The doors ease apart gently, revealing the quiet lobby beyond, and the patient passenger who has been waiting there throughout this entire careful process, though of course to them, only a few brief seconds have passed. They step forward into the softly lit car, and the invisible infrared beam along the doorway registers their presence gently, simply another quiet confirmation passed silently through the system. Once inside, the passenger reaches toward the small panel of glowing buttons and presses one, selecting whichever floor they hope to reach. And here, the entire beautiful process we've just followed begins again, in miniature, in reverse, in continuation. That small press closes its own small circuit. A signal travels once more through hidden wiring, arriving once more at the controller, which considers this new request exactly as carefully, exactly as calmly as it considered the very first one. The doors, after a brief, patient pause, begin their own gentle closing motion, the infrared beam watching quietly the entire time, ready to pause and reopen should anything unexpected pass through the doorway. Once fully closed, the interlocks confirm their agreement once more, the safety circuit completes its steady loop once more, and the holding brake releases once more, allowing the motor to begin its familiar gentle turn. The sheave rotates. The ropes shift along their grooves. The car begins to rise now, rather than descend, carrying its one quiet passenger upward through the shaft, while on the other side of the rope, the counterweight begins its own downward journey, once again in perfect, careful opposition. Floor by floor, the small position sensors continue their soft, repeated confirmations. Here now, here now, here now. The controller listens to each one, continuously aware, continuously certain of exactly where the car rests within its long vertical path. And as the car approaches its new destination, the entire gentle sequence unfolds once more, the slow easing of speed, the careful leveling, the quiet stop, the confirmed safety conditions, and finally, the soft opening of the doors. The passenger steps out into whatever quiet hallway awaits them, and the doors close gently behind them, the car settling back into its own patient stillness, ready once again for whatever request might come next, whenever it might arrive. It's worth pausing here, gently, to consider everything that has just happened, this whole quiet, extraordinary sequence of coordination, unfolding within what felt to the passenger themselves like nothing more than a simple, ordinary elevator ride. A button was pressed, a signal traveled, a controller considered and confirmed. A motor turned, smoothly and gradually. A counterweight balanced its quiet opposite motion. Sensors tracked position continuously, without pause. Doors opened and closed with careful precision, watched over by invisible beams of light. Brakes released and engaged at precisely the right moments. And through it all, dozens, perhaps hundreds of these tiny systems and processes work together, quietly, invisibly, in careful cooperation, simply to carry one person gently from one floor to another. This is worth resting on softly as we near the end of our long journey together tonight. A single elevator ride, something so ordinary, so unremarkable, so easily forgotten the moment it's finished, is in truth an extraordinary act of quiet coordination. Thousands of tiny systems, some mechanical, some electrical, some purely informational, all working together in careful harmony, none of them announcing themselves, none of them asking for attention, simply performing their part, gently, reliably, and then returning to stillness the moment their part is complete. Let's imagine once more this same building settling back into quiet after this small journey has finished. The passenger has gone, walking softly away into whatever quiet corridor or open night awaits them. The elevator car rests once again, doors closed, light glowing softly over an empty room. The motor has cooled again, its rotation stilled. The counterweight hangs once more in perfect balance, and the controller, in its quiet cabinet, continues its own soft, steady watch, small lights blinking slowly, patiently, waiting for whatever small request might arrive next, whether in a few minutes or not until morning. This is the quiet truth beneath every elevator ride you've ever taken and every one you ever will. Behind the simplicity of stepping into a small room and pressing a button lies an entire hidden orchestra of careful engineering, playing its slow, gentle music continuously, whether or not anyone is there to listen. Buttons and controllers, sensors and motors, drives and brakes, counterweights and cables, doors and interlocks, all of it working together, quietly, endlessly, patiently, so that a single ordinary journey between two floors can feel like nothing at all, like the simplest thing in the world, precisely because so much careful thought has gone into making it feel that way. And now, as this small imagined journey comes gently to its close, let's allow ourselves to settle as well, into that same quiet stillness the elevator now rests in. No more requests to consider tonight. No more signals traveling through hidden wires. Just soft light and quiet machinery, and the long, patient hum of a system that will remain ready, exactly as it is, for as long as it needs to, until the next small hand reaches out, gently, and begins this whole graceful process once again. Rest now in that same quiet readiness. There is nothing more to follow, nothing more to track, nothing more required of you at all. Just stillness and soft light, and the gentle knowledge that somewhere, patiently, reliably, systems continue their quiet work, so that you don't have to think of them again until you need them, floors away, mornings away, softly waiting, exactly as you are now. Let's return once more to a tall commercial building late at night, standing quietly beneath a dark sky, its lower floors glowing faintly through tinted glass, its lobby resting in soft, dimmed light. The hallways beyond are empty now, stretching out in long, quiet lines, their carpets muting even the smallest imagined footstep. and along one wall of this still lobby, a set of polished elevator doors waits, closed and calm, giving no hint at all of what lies just beyond them. Because behind those doors, hidden from the ordinary world of hallways and lobbies and softly lit reception desks, an entire vertical world continues upward, floor after floor, through the very center of the building. Tonight, let's take a slow, quiet journey through that hidden space, not as passengers riding briefly from one floor to another, but simply as quiet observers, drifting gently upward through the shaft itself, taking our time, noticing things most people never notice at all. This tall vertical passage is called the hoistway, though many simply call it the elevator shaft. It runs the entire height of the building, from the lowest level all the way to the highest, a single continuous column of space that connects every floor together in a way no hallway or staircase ever could. If you could see through the walls of this building right now, this shaft would appear as a long, narrow ribbon of quiet darkness running straight up through the center of the structure, floor after floor after floor, each level passing by in careful, measured succession. Let's imagine drifting gently into this space now, past the closed doors, into the quiet air beyond them. It's dim in here, lit only by small maintenance lights spaced occasionally along the walls, enough to see the careful outlines of cables and rails, but nothing more, nothing bright, nothing insistent. The air feels still, slightly cool, carrying the faint metallic scent that always seems to belong to spaces like this, the scent of steel and quiet machinery resting patiently in the dark. Somewhere within this vertical space, the elevator cab rests, exactly where its last journey left it, motionless, its own small light glowing softly inside, casting a gentle, contained warmth into the surrounding darkness. From out here, in the wider space of the shaft, you can see the cab is not simply floating in open air. It's held, carefully and precisely, by a whole quiet arrangement of components surrounding it, rails running along its sides, cables stretching upward from its roof, a counterweight resting somewhere nearby, connected to it by the same steel ropes that pass, high above, over a single grooved wheel. Everything is exactly where it should be. Everything rests in careful relationship to everything else, the way the pieces of a quiet, patient machine always do. Let's move closer now, gently, toward the rails themselves, because they deserve some quiet attention of their own. Running the entire height of the shaft, fixed firmly to the walls on either side, two long steel rails stretch upward in perfectly straight, perfectly vertical lines. They begin down at the very bottom of the building and continue, uninterrupted, all the way to the top, like two long, quiet threads holding the whole vertical journey together. These rails exist for one simple, steady purpose. They guide the cab's movement, ensuring it always travels in a straight, predictable line, never drifting sideways, never swaying, never uncertain about its path. Every single time the elevator rises or falls, it follows these exact same rails, the exact same careful path, trip after trip, day after day, year after year. There's something very calming in that kind of consistency, isn't there? A path that never changes, a boundary that has already been decided long before this particular journey ever began. Attached to the frame of the cab, small roller guides rest gently against these rails, turning softly as the car moves, keeping everything aligned with quiet precision. These rollers are small, unremarkable pieces of hardware, easily overlooked, and yet they carry an important responsibility, translating the cab's vertical motion into something smooth and steady, rather than loose or uncertain. If you rested your hand against the inside wall of a moving elevator, you might feel the faintest whisper of vibration from these rollers, so gentle it barely registers as anything at all, simply a soft reminder that the cab remains held, carefully, exactly where it should be. The rails themselves are installed with remarkable care, adjusted and aligned so precisely that even the smallest imperfection would be noticeable in the smoothness of the ride. Technicians measure their straightness patiently, checking and rechecking alignment along the entire height of the shaft, ensuring that from the very first floor to the very last, the path remains exactly as steady, exactly as true. This is one of those quiet, invisible efforts that most people will never think about, and yet it shapes every single ride taken within this building, invisibly, continuously, for as long as the elevator remains in service. Let's drift a little further into the shaft now and look upward toward the very top, where the ropes stretch away into the dimness above. These are sometimes called suspension ropes, thick steel cables, several of them working together in parallel, each one capable of carrying significant weight on its own, layered together for strength and redundancy, so that no single rope ever carries the full burden alone. In some newer elevator systems, these ropes have been replaced by flat steel belts instead, thinner, quieter, and often more compact, though they perform exactly the same essential role. These ropes, or belts, rise from the top of the cab, stretching upward through the shaft until they reach a large grooved wheel called a sheave, resting patiently at the very top of this vertical space. From there, they curve gently over its surface and descend once more, this time connecting not to the cab, but to the counterweight, resting quietly somewhere else within the shaft, often toward the back, moving along its own separate set of guide rails. Let's picture this counterweight now, resting nearby in the darkness, a solid, heavy shape, still and patient, connected invisibly to the cab through this long loop of cable passing over the sheave above. And let's remember gently what we explored earlier in our journey together. This counterweight is not simply extra weight, added without purpose. It exists specifically to balance much of the cab's own weight, so that whenever the cab rises, the counterweight lowers, and whenever the cab lowers, the counterweight rises, always in careful, quiet opposition. The elevator is not fighting gravity, it is working with balance. This idea is worth resting on again, slowly, because it captures something true not only about how elevators move, but about how so many well-designed systems function. Nothing here strains against the natural pull of the world. Instead, that pull has been arranged carefully, thoughtfully, into a state of quiet equilibrium, so that only a small amount of effort, offered gently by the motor above, is ever needed to shift that balance in one direction or another. If you could watch right now as the cab and counterweight move together, you would see something almost peaceful in their motion. Two shapes, connected by the same length of cable, moving in patient opposition, one always compensating for the other, neither one ever straining, neither one ever working entirely alone. It's a quiet kind of cooperation, playing out silently within the walls of this building every single time the elevator moves, whether or not anyone happens to be riding inside. Let's think now, gently, about how this whole system always seems to know exactly where the cab happens to be resting at any given moment, day or night. Scattered along the height of the shaft, spaced carefully at each floor, small position sensors wait quietly in the dark, some using tiny magnets, others using small mechanical switches, each one designed simply to notice, gently, whenever the cab passes by. As the cab moves through the shaft, these sensors send small signals traveling along hidden wiring back toward the controller resting somewhere else in the building. Each signal offers the same simple confirmation again and again. Here now, here now, here now. This isn't a single measurement taken once and then forgotten. It's a continuous, ongoing whisper of awareness, repeated constantly throughout the cab's entire journey, ensuring that the controller always knows with quiet certainty exactly where the cab rests within the vertical space of the shaft. Near the very top and very bottom of the shaft, additional devices called limit switches wait patiently as well, quiet safeguards designed to notice if the cab were ever to travel further than intended in either direction. Under ordinary circumstances, these switches remain completely inactive, resting unused through the entire life of the elevator, present simply as one more gentle layer of quiet reassurance, watching for a moment that, in a well-maintained system, essentially never arrives. All of these signals, the steady stream of position confirmations, the quiet readiness of the limit switches, the ongoing feedback traveling constantly through hidden wiring, form a kind of continuous, invisible conversation happening throughout the shaft, every moment of every day, even now, in the deep stillness of night, even when the cab itself remains completely motionless. The system is always listening. The system always knows, not because it needs to think especially hard about it, but simply because this constant, gentle awareness has been built quietly into every part of its design. Let's drift downward now, slowly, past the resting cab, past the rails and the sensors, down toward the very bottom of the shaft, to a space that few people ever see or think about at all. This is called the pit, a shallow, quiet chamber resting below the lowest floor the elevator ever visits, the very base of this whole tall, vertical world. It's dim down here, lit only by a small maintenance light, casting soft shadows across simple concrete and steel. Resting quietly within this space are the buffers we spoke of earlier in our journey, springs or hydraulic cushions waiting patiently, hopeful that they will remain forever unused. This space also serves as an inspection area, a place where technicians can pause safely, quietly, checking the underside of the shaft, the lower reaches of the guide rails, the base of the counterweight's own path, ensuring that everything down here remains exactly as steady, exactly as reliable as everything above. There's something peaceful in imagining this small hidden space, resting at the very bottom of such a tall structure, quietly holding a handful of careful safety devices that almost never need to act, existing simply as one more patient layer of reassurance, tucked away below everything else, unseen, unnoticed, and yet fully present, fully prepared. Let's rise now, gently, back up through the entire height of the shaft, past the pit, past the counterweight resting in its quiet balance, past the long, straight guide rails, past the small sensors offering their continuous whisper of position, up toward the very top, where the machine itself waits. In many buildings, this space is a proper machine room, a small enclosed area resting just above the shaft, holding the motor, the sheave, and the control cabinet all together in one quiet space. In other buildings, especially newer ones, this same equipment has been made smaller and more compact, tucked directly into the shaft itself, taking up only a modest amount of space near the very top, resting quietly alongside the rails and cables it helps to control. These are sometimes called machine roomless systems, though of course the essential equipment remains exactly the same, simply arranged a little differently, a little more efficiently, within the building's overall design. Wherever this equipment happens to rest, the scene remains much the same. A motor, cool and still at this late hour, resting on its steel frame. A sheave, unmoving, its grooves holding the ropes in careful, patient stillness. And nearby, a control cabinet, its surface dotted with small indicator lights, blinking slowly and evenly in the dim light of this quiet room, confirming gently, again and again, that every part of the system remains exactly as it should be. These indicator lights are worth pausing on for a moment because they offer a small, visible glimpse into all the invisible awareness we've been describing throughout this journey. Each blink represents some small confirmation happening quietly within the system, a sensor reporting its status, a safety circuit completing its steady loop, a drive confirming that it remains ready, prepared, calm. None of these blinks mean anything dramatic. They simply mean the system continues watching itself, continues checking itself, continues resting in that same quiet state of readiness that we've returned to so many times tonight. If you could stand in this small room right now, you would likely notice how peaceful it feels, despite being filled with machinery capable of lifting so much weight so many floors into the air. There's no sense of strain here, no sense of struggle, just quiet metal and soft light, and the faint, steady hum of electrical current moving gently through wires, keeping everything alert, keeping everything prepared, without asking anything more of the space than simple, patient stillness. Let's take a slow, final look now, back down the entire length of this shaft we've been exploring together, from the machine room at the very top, down through the long, straight guide rails, past the quiet resting cab, past the counterweight hanging in its own careful balance, past the small sensors offering their continuous whisper of position, down to the shallow pit resting at the very bottom, its buffers waiting patiently in the dark. This entire vertical world exists within the walls of just one building, hidden quietly behind ordinary doors that most people pass by every single day without a second thought. And yet, at this very moment, all around the world, countless other buildings hold their own versions of this exact same hidden world. Office towers standing quietly in distant cities, apartment buildings resting along softly lit streets, hospitals humming faintly through the night, hotels holding their guests in gentle temporary stillness, each one holding its own shaft, its own rails, its own counterweight, its own quiet controller listening patiently in the dark. Somewhere right now, in a city you may have never visited, an elevator very much like this one rests in its own quiet shaft, its own small lights glowing softly, its own sensors watching gently over its own careful stillness. And in another city, another elevator does the same, and another, spread out across the entire world, each one a small hidden world of its own, each one holding the same careful balance of motors and cables, rails and sensors, brakes and controllers, all resting quietly, all prepared patiently, all waiting for whatever tomorrow might gently bring. There is something very soothing in imagining all of these hidden vertical worlds at once, scattered so widely across so many buildings, and yet each one so similar in its quiet purpose, each one built on the very same gentle principles of balance and readiness we've explored together tonight. Thousands upon thousands of elevators, resting now in stillness all around the world, in buildings of every shape and size and purpose, each one holding its own small, patient version of everything we've walked through together in this shaft tonight. And of course, not every building uses its elevators in quite the same way. A quiet office tower rests differently at night than a busy hospital, which never truly sleeps at all. A tall residential building holds a different daily rhythm than a hotel welcoming guests at every hour, or a shopping center opening its doors each morning to an entirely different kind of crowd. Each of these buildings asks something slightly different of its elevators, shapes their systems slightly differently, adjusts their patterns of readiness to match the particular life of the space they serve. We'll explore some of those differences gently, together, another time, drifting through hospitals and hotels and quiet apartment towers, noticing how the same essential engineering we've walked through tonight adapts itself calmly to so many different kinds of buildings, so many different kinds of lives. But for now, let's simply rest here, in this one quiet shaft, in this one still building, letting our attention settle gently over everything we've seen tonight. The rails, straight and true, the cables, holding their careful balance, the counterweight, resting in patient opposition, the sensors, whispering their continuous confirmation, the pit, waiting quietly at the bottom, the machine room, humming softly at the top. All of it held together, all of it working quietly, all of it simply waiting, the way you are welcome to simply rest now too, held gently, unhurried, safe within the soft stillness of your own quiet night.